I want to thank Mark Humphries for coming on Brain Science to tell us about his new book, The Spike, An Epic Journey Through the Brain in 2.1 Seconds. This book is a wonderfully clear description of our knowledge of how action potentials are generated, along with a few of the surprising discoveries that have resulted from the new techniques that make it possible not only to record from hundreds of neurons spontaneously, but also to appreciate that neurons are doing computations even when they don't generate spikes or action potential. This is a book that can be enjoyed by listeners of all backgrounds. I found the discovery of the so-called dark neurons especially fascinating. There's no exact definition of a dark neuron, but think of these as the neurons that are firing less than once a minute. I also want to emphasize how discovering these neurons required new techniques that allow researchers to detect and observe neurons that aren't firing. Then there is something of an overlap between the idea of spontaneous activity and what Humphries calls type 2 dark neurons, since these are neurons that are not firing in response to any obvious external inputs. One of the key techniques that we discussed was the ability to record from increasingly large numbers of neurons simultaneously. This not only allows us to appreciate the role of dark neurons and the fact that much of what the brain does is spontaneous, that is not generated by inputs from the outside world, but it also led to the key discovery that decoding should probably be based on populations of neurons rather than at the level of a single neuron. I should mention that that idea is also driving current successful attempts to create brain-machine interfaces that allow patients to control things like artificial limbs. Finally, we explored Humphries' take on the possible role of the brain's spontaneous activity. This is a topic we discussed last year in episode 172 and 174. Obviously, this is an area of active interest, but Humphries suggests a couple of possibilities. One is that this spontaneous activity keeps neurons near threshold so that they will fire more quickly when an external signal appears. Another possibility is that the neurons are doing some sort of computation that is of importance to the predictive abilities of the brain. And he actually said that maybe this spontaneous activity is how the brain does its prediction.